Hello, this is our project on petroleum refining by William Fox and Davis Wall. What is petroleum? Petroleum is a liquid mixture of hydrocarbons that is present in certain rock strata and can be extracted and refined to produce fuels including gasoline, kerosene, and diesel oil. Petroleum that comes from the ground is a mixture of several thousand organic compounds with 4 to several hundred carbon atoms. The location that the petroleum is gathered can change the makeup of the petroleum. For example, Texas crude oils contains a small amount of sulfur containing molecules, and Saudi Arabian oil has a larger amount of sulfur contained.
Millions of years ago, a large quantity of organic materials fossilized under the seabed in an oxygenless water known as stagnant or in an anoxic sediment. As further layers settled over the source rock, the intense heat and pressure causes the fossilized organic matter to transition into a wax-like kerogen through the process of diagenesis. After several years of additional heat and pressure, the kerogen will go through catagenesis, where they will become liquid and gas hydrocarbons. There are two classes of hydrocarbons: low hydrogen to carbon ratio, which will result in anthraquinone, or high hydrogen to carbon ratio, which will result in methane. Because the reaction is sealed off from external reactants, the hydrocarbon composition is entirely dependent on the stoichiometry of the fossils. Uh, Algae versus bacteria, also the quantity of carbon, because there's a uh, the limiting factor is the carbon, not the hydrogen. How is petroleum mined and gathered? Once the oil prospector finds an oil trap, which is a pocket of petroleum sealed between impervious rock layers, an oil rig is used to drill a bore into the petroleum layer, and a steel pipe is installed to collect the oil. Once the bore is secured, holes are made in the base of the well, and valves known as Christmas trees are used to control the flow and pressure of petroleum as collected. Christmas trees are actually named for a street racing term, not the actual Christmas tree, interestingly enough. Stages of recovery. Once the bore is dug and equipped to collect the oil, the extraction process includes 3 stages of oil recovery. The primary stage is the easiest and most convenient process, where the oil shoots itself through the pipes because of the natural pressure built into the reservoir. This usually yields 5 to 15% of the petroleum. When the natural pressure becomes insufficient to upstream the oil, the secondary stage implements artificial pressure in the form of steam or gases like carbon dioxide to force the oil upward. This results in somewhere around 30% of the oil being extracted. Finally, enhanced recovery uses heat to lower the viscosity of the oil and thus decrease the pressure required to move the oil. With the additional 5 to 15% of the TEOR, or enhanced recovery process, the process extracts roughly 60% of the petroleum inside the oil trap.
Usage. Petroleum is the largest United States energy source, and we use it for vehicles, to heat buildings, and to produce electricity. In 2018, about 20.5 million barrels of petroleum was used each day. 69% of that was used for transportation, 25% for industrial, 3% for residential, 2% for commercial, 1% for electrical power. Gasoline is the most used petroleum product of about 9.5 million barrels per day, or 45%.
The separation process. The first step in crude oil refinement involves separating all the different hydrocarbon compounds according to weight. This is achieved by the process of atmospheric distillation, where the unrefined petroleum is heated in a 60-meter deep column at 673 kelvins. The oils will vaporize to the top of the cylinder, leaving a residue containing highly viscous materials like asphalt at the bottom. This residue will repeat the process at a higher temperature to produce heavier oils like diesel. For the vapor, it will ascend and condense at various temperatures on trays designed to hold the liquefied form of the substance. These varying condensation levels are known as petroleum cuts. From here, the specific oil molecules will begin the conversion process to be refined.
Conversion. The conversion of petroleum to most use of the petroleum products, gasoline, is with the 3 steps. Distillation, the action of purifying a liquid by a process of heating and cooling, cracking, break or cause to break without a complete separation of the parts, reforming, subject to hydrocarbons to a catalytic process in which the straight chain molecules are converted to branch forms for use in gasoline. The process. First, the petroleum is heated to 400 degrees Celsius. After it is heated, the petroleum is a mixture of liquid and vapor. This is called the feedstock and is then moved to the refining tower. The components with the lowest boiling point condense at the top because it is cooler, and the components with the higher boiling point condense at the bottom, and at each level of the refining tower is a different composition of the petroleum mixture. There are many different ways to refine petroleum, and it depends mainly on where it is gathered from. Petroleum contains many organic compounds containing nitrogen, oxygen, dissolved metals, and inorganic salts, and sulfur. The main reason to treat petroleum is to remove unwanted sulfur compounds. Treatment is done in the middle of the refining process or near the end of the process. Sweetening is a process in petroleum treatment that removes the sulfur to improve color, odor, and oxidation stability. It also decreases the concentration of carbon dioxide in the oil.
Refining begins with a process called distilling.
Also known as separation.
After oil is superheated, it becomes vapor. The vapor is fed into the distillation unit. As it rises and cools, the vapor turns back into a liquid. Using stacks of trays, the liquid is easily collected and separated by weight. The lighter and medium weight liquids require less processing before they're ready to be used in cars and trucks. The heavier liquids need more processing to become useful. A process called cracking is used to maximize the usefulness of heavy oil. Heavy oil has long strings of carbon and hydrogen molecules. Using a catalyst, these molecules can be broken into smaller chains, transforming the heavy oil into lighter, more valuable fluids. Reforming is a process that increases the amount of gasoline produced from crude oil. One of the products separated in the distilling process is a liquid called naphtha. The number of carbon atoms in naphtha is about the same as the number found in gasoline, but their structure is more complex. Reforming rearranges the naphtha molecule, turning it into a usable, gasoline-like molecule. Blending is a process of mixing different refinery products to make finished petroleum fuels. Gasoline, for example, is blended to achieve octane standards, creating the grades of gasoline you see at the pump: regular, mid-grade, and premium, that are necessary to meet the needs of specific engine types. Treating is a process used to produce cleaner gasoline, which helps protect both the environment and our health. Gasoline molecules contain impurities like sulfur that can be removed. When the molecules are heated and come in contact with a special catalyst, a chemical reaction occurs that strips the sulfur away. These sulfur compounds are used as fertilizers and in pharmaceuticals. Nothing goes to waste in a refinery.